Looking at these patients in 1989 as a clinician, and didn't know what I was doing. Psychiatrist sent me patients because he felt they didn't have depression, but they were treated for depression, and he said, I'm a serious psychiatrist, and Hamilton scores are 0, so it can be depression, but I don't see what they have. And at the time I was in cardiology, in the cardiology department, looking at exercise physiology studies, and these people had an extremely low exercise capacity, and that was the only thing I could find. So after a sabbatical in the United States, where I learned about the late tau epidemic, it became clear that we also in Belgium had patients like this. So in the 90s, we started doing research, more pathophysiology, and it's only in the last 10 years that we really looked at proteomics, genomics, new infections, and trying to subgroup patients, because this is not a homogeneous disorder itself, and even in time, over time, it's a very heterogeneous disorder. And I already will make my final conclusion now, and you will see where I'm going. But today, I think the chronic fatigue syndrome, you have to be genetically predisposed, you have to be, certain environmental factors have to be present. It's elicited by usually a cold infection, which I will elaborate on more, and it progressively leads to a situation where you get the autoimmune disease. So at the beginning, the infectious component is very important, but in later stages of the disease, the disease becomes more and more an autoimmune disease. So before the year 2000, there was only the Ampligen study. There were small intervention studies with DHEA, with other drugs, but there was not really an attempt to diagnose nor treat ME/CFS. So in 1998, we started a group in Brussels just to look at the immune dysfunctions, and we worked together with Bernard Bleu from France, and with Robert Sedalnik from Temple University in Philadelphia, and we did over 3,000 in vitro experiments on PBMCs of patients. So we didn't start with animal work, but we really took the PBMCs of the patients, and on those PBMCs all sorts of experiments were done to see whether we could find some pathophysiological things. And this came out as a result of this research. I cannot describe all these 3,000 experiments, but this was the model that we published in 2002, which shows that there is infection, there's food-related problems, there's metals and chemicals involved, there's certainly genetic background, and we looked at 3 major pathways that are related to viral infections and to food-mediated inflammation and to nitric oxide. So I will come back on this slide later, because I still use this today to look at the whole disease, and I try to stage every patient according to the abnormalities found on this slide. But we don't do all these tests anymore, because we know that these abnormalities are present once you know in the whole thing that a few things are abnormal. But what we found is that the Th17 pathway is erroneously stimulated in CFS by the fact that the RNA-L is cleaved, and fragments of the RNA-L leads to channelopathies. Here I think there's also an overlap with other diseases like MS, and also in autism. I think there is overlap here, because one of the experiments we did in vitro showed that this channelopathy, as a result of this cleavage, makes you much more sensitive to mercury. So cells die at a very low concentration of mercury if RNA-L is cleaved, and fragments
come into the channels of the cells. Also, the 2,5-A-like proteins that are induced in the 2,5-A pathway when it's stimulated, they create thyroid hormone resistance. And not only they are going to sit on the T3 receptor and make it impossible for the T3 to have its activity, but with time they will also destroy the T3 receptor. And it explains why ME/CFS, after 25 to 30 years in some people, becomes irreversible. They get thyroid hormone, they look hypothyroid, hyperthyroidism, but they get T3, they get T4, but that doesn't make a difference. And so in some people it really leads to a destruction of T3 receptors on those cells that have T3. We looked at the relation of food and other things that could induce inflammation, and we found that high elastase activity is present in the majority of patients, and we found that 66%, about 2/3 of the cleavage of RNA-seL is related to elastase. There are other proteases that are elevated in this inflammatory state which cleave RNA-seL, but elastase is the one that is quantitatively the most present, so that can make you give action. There are about 29 substances in pharmacology that inhibit elastase or are elastase inhibitors. And for example, beta-lactam antibiotics. A lot of patients say they feel a lot better when they get amoxicillin. For example, well, beta-lactam antibiotics are elastase inhibitors. And a second system is the protein kinase activity, which is increased in all these patients. Another American group has looked at it very extensively, and this is also related to increased nitric oxide. The reason why we use such high doses of B12 in the patients is because peroxynitrate, which is related to oxidation of nitric oxide, is in fact inactivated by B12. So we came to a model, and I'm going to go into this much more, where we look at these three systems and see what happens in these patients. Now, on the regulation of the T-cell immunity in general, and I'm going to make just a summary, we know that Th1 immunity is usually depressed in CFS patients. Th2 is either normal or activated, and there's an excess activity of Th17. So the ratio Th1, Th2 is abnormal in favor of Th2, and Th17 is usually less than 5% of the total activity of a T helper cells is increased in these patients. Now, excess of Th17 leads to autoimmunity and leads to inflammation. Some patients have extreme allergies, but in fact we see more intolerances, food intolerances and intolerance in general, than allergies in these patients. So the Th2 is not the major problem. A major problem is a depression of Th1, which then leads to hypersensitivities, leads to reactivation of certain viruses like herpes viruses, and leads also to persistence of certain bacteria like mycoplasmas, chlamydia, and other intracellular bacteria that we cannot fight when we don't have an adequate Th1 immunity. Now, the Th17 pathway is really important for inflammatory and autoimmune processes, because the Th17 was named after IL-17, and it produces IL-17, IL-22, and IL-26, and they're involved in allergic inflammation, in asthma, in rheumatoid arthritis, in multiple sclerosis, and a lot of intestinal diseases. And we see there's a lot of overlap in the symptoms and in the pathophysiology of chronic fatigue syndrome with these diseases. The clinical abnormalities in ME/CFS are consistent with the Th17 activation, with the Th1, Th2 imbalance, with the inflammation, and with the neurocognitive problems. Th17 cells promote blood-brain barrier disruption and central nervous system inflammation. So again, we come to a model that is derived of all this research. And already in 2002, we said that it's probably endogenous retroviruses, and I know it's dangerous to talk about HERVs, but I'm going to do it anyway. Endogenous retroviruses and certain repetitive structures in these retroviruses are responsible for PKR dysregulation in monocytes, and indirectly also for the system that dysregulates RNA-seL. And when you get overactivation of these systems, COX-2, inducible nitric oxide, and FKB, you are going to go in a pathway where NO arises, where NO is going to be oxidized, and part of the oxygen that is not taken up by the tissues but goes lost underway between respiration and the muscles is going into nitric oxide and is becoming peroxynitrate. Now, NO is going to interact with the ryanine receptors and causes muscle weakness, not always paralysis, but weakness. And the strong free radical peroxynitrate decreases NK cell and T cell lymphocyte toxicity, which also dysregulates glutamate in the brain and is co-responsible. It's one of the factors that we think is responsible for low CRH, and low CRH stands also for low serotonin. And in this explains part of the Th1 immune deficiency. In acute MS, in the relapsing remitting MS, when acute bout of MS, one knows that NO is decreased. So we get the other way. We get a Th1 switch here, we get a Th2 switch, but we get a Th1 switch. And when the NK cells and T cells are overactive, you get a Th1 immune activation. You get myelin degradation through two mechanisms. First of all, direct to toxicity, but also due to glutamate upregulation, which is toxic for the oligodendrocytes, which you need to repair your myelin. So you need to repair your myelin with your oligodendrocytes, and if there is a toxic component there, you will have a slow myelin reparation. Now, genetic predisposition of Th17 in CFS ME patients, something we published. We see a lower frequency of a subtype of IL-17, IL-17F, and this IL-17 sequence variant is lower in CFS ME patients. And this has a strong pro-inflammatory effect, and we know that this variant is present in 6% of the patients versus 31% of the matched healthy controls, and we found that in a Belgian Dutch population, also in a Norwegian population. So we suggest here that Th17 activation contributes to the pathogenesis of the disease, and so it will be interesting for any drug related to therapy in ME/CFS to see what happens with Th17 as a result of it. Other biomarkers of CFS-ME are known, and persistent inflammation, reduced function of NK cells, altered cytokine expression. Fletcher showed that 10 of 16 cytokines were elevated, and they're mainly Th2, Th17, and lowering of Th1 related cytokines, chronic lymphocyte activation, high numbers of NK and T cells express CD26, and then abnormalities in stress response, increased neuropeptide Y. And then you have the studies by Donovan, which has the autopsy cases, which is very interesting in the non-specific changes in muscle. There is CNS deposition of corpora amyliacea, and we come very close to neuroinflammation. What happens in neuroinflammation? There is non-specific gliosis, in those patients who died of a status of ME/CFS. Also, what is found is chronic inflammatory process affecting the dorsal root ganglia with low level destruction and loss of ganglial cells. And you heard about the gray matter. Other studies have shown that there is loss of gray matter.